This is a long and pretty multi-step problem, but what we can keep in mind here is all we really want to know is where are the zeros and where are the islands and what are the islands' sizes. So we know we can change one zero to a 1 to make potentially a bigger island. So there are a few cases we can consider. If we are given a grid that has no zeros at all, then clearly our biggest island is going to be whatever the biggest island is. If we have zeros, but they are all surrounded by islands, then we cannot combine two islands. However, the way we can really use this problem to our benefit when we want to combine an island is if we have a zero and it is somehow four-directionally connected to multiple islands that are different, then we can really create a bigger island. So as you can see, one of the main things we have to tackle in this problem is how to figure out the size of an island, because we need to know the island sizes before we can really make a bigger island and know what the size of the largest island we can make is. So we're going to start out by doing a depth first search and then finding the sizes of the islands. So we can start just by setting up like a for loop, a nested for loop for how we would go through these island grids. The base for how to do this problem is pretty similar to the number of islands problem and the max size of an island problem. So we're going to be building off of those foundations. So the way we know what an island size is we can keep a hash map that holds an island's ID, a unique island ID, and its size. And when we keep an island's ID, we are going to want to make sure that we do not confuse this ID value for a 1 or a 0. So for example, if we try to keep islands in the map just based on like counting up from 1, that would be a problem, as if it were 1 we could be confused between like if this is an island or if it's like something that's already inside our map. So what we can do is we can keep the island ID as a negative value starting from -1. So I'm going to have a map of the island ID to size. And again, I feel like my previous explanation was not very good, but the reason why this matters is because we want to edit the grid so that all the ones inside our grid are going to be changed to an island ID. And all pieces of land, aka all ones that are connected with other ones in one island, are going to share an island ID. And when we're done with the depth first search, we're going to update our island ID to size map with the size of that island for that island ID. So I'm going to demonstrate this a little bit better here. So similar to the max size of island problem, we can do a DFS that returns an integer size. We're just going to pass in our coordinates. And of course this DFS can only run if the value of the grid is going to be equal to 1. So looking into our DFS, First, you're going to want to do the basic checks for any DFS method to ensure that this is valid and in bounds. And we want to make sure it is a piece of land we have not seen before. And remember, we want to actually edit each of these valid cells as like the valid pieces of land to be the island ID. So we're going to actually also want to pass in the island counter. And this counter is going to tell us what we are going to edit our value in the grid to. This is also our way of marking that we have visited this piece of land, because the next time if you re-arrive this piece of land, you will notice that it is no longer a 1. And remember, we want to have these be negative values for the island IDs, just in case if it turns out to be 1, we don't want to confuse it with the piece of land. So when we're done with the DFS, we're going to want to increment the island counter. But let's first finish up this DFS. Because we just want to return the size, we're just going to want to continue the DFS in all 4 directions. Yeah, so now our DFS is nice and done. So once we are done with the size, what we're going to want to do is, given this island counter, we are now going to want to put that to our map. So what we're going to do is we're going to add this. And remember, the way we've been calculating island counter is -1 times the island counter plus 1. So that's exactly how we're going to be inputting it into our map, because we want to be able to map back to the values we have edited in the grid. Now we have a good way of knowing what the sizes of each of the islands are, and whether two ones are going to be, or 2 parts of an island are part of the same island. When we will know they are part of the same island once we see that the island ID is the same inside the map. Alright, so that looks good. The next thing we want to do after we have recorded the sizes of all of our islands and we have a way to know its size is we want to create a way so that for all of the zeros, I guess the first thing we can do is find a method to go through the entire grid again and look for the zeros. And for each of the zeros, we want to see if we converted this 0 to a 1, how much bigger could it make the largest island size? Speaking of which, we do need a max island size to start with. And actually, one thing we can do is to make this a little more efficient. When we calculate the sizes of our islands inside our first nested for loop, we can update the max island size to be whatever the max size of the existing islands is. This exists just in case we see that there aren't any zeros. We'll still just be able to return the largest size of the existing islands. So yeah, inside of our second nested for loop, if the value is currently a 0, we're going to want to consider a few things. So really what we want to do is we want to look in 4 directions above this cell to see if, first of all, these are islands, and second of all, if they are part of different islands. So I'm going to initialize 4 variables: top, bottom, left, and right. So the way we can really increase the island size is if we find that there are just like islands that are separate in all 4 directions of this 0 and they are somehow not connected to each other. That way we can basically increase the entire island size by like 4 by connecting them all together and adding the 0 itself. But we also need to be careful because it's possible that this 0 is just surrounded by a single island. So that's why we're going to have to look inside our island ID to size map to check if the ID is the same or different. And actually, we're also going to want to create a priority queue or linked list to be able to add these together. And we want this to, so the reason why I have these in arrays is because the first value will be the island ID. Second value will be size. And we want this to be in reverse sorted order so that we can get the biggest size island to start. The reason being that, let's say we have 2 islands that are of different sizes, but they might somehow like touch, they might somehow take up the same space. We're going to want to take the one that is larger first. So yeah. Actually, I do not think we necessarily need this. Let's see. So what we can do to make sure we do not add the same island multiple times is we can have a set of the integer of the island IDs. So first of all, if the we can look above this current cell, we can say that the top value is going to be equal to whatever is the size of the values right above it. So basically what this does is first grid I of j minus 1 will check for the island ID of the value directly above our current 0. So we're going to look inside our island ID to size, and actually this needs to be get or default because it's possible that this is also a 0, so it's not even inside of our map. and then top is going to be whatever this value is. Now, let's say we do get some value for top, which is not 0. Then if top is not equal to 0, then what we're going to have to do is we have to add this ID to the set to make sure that we do not accidentally add the same island multiple times, just in case once we get to like the bottom, left, and right, if it's the same island with the same island ID, we do not want to add it multiple times. So we're going to see this in more detail here. So let's say we're able to look one below without stepping out of bounds. Then if this value, like if island IDs does not already contain the if it does not already contain the value here, value at this specific index, then we can make sure bottom is basically the same as this. We want to update bottom with whatever the value is below. However, if it already contains this ID, that means it's the very same island that was already captured above. So actually the rest of the code is going to be pretty similar to this. So we're going to start with this. And we're going to want to do something similar here. And we're going to want to make this left. Oh, and I forgot one important thing. Similar to the code for top, if the bottom is not equal to 0, as in we were actually able to add something, then we're going to want to add the ID for this as well, just in case like the island to that's below it is going to be the same island that is to its left or to its right. And obviously the code to find whether this works for what's to the right is going to be very, very similar to all of this code. And this needs to be 0. And this is going to be looking to the right. Alright, okay. So yeah, now all we have to do is just add this together. So we're going to add together all these values. But we're going to want to make sure we also add 1, because this 0 is going to be like the glue that connects all these potential different islands together. And then, yeah, we also want to check against the current maximum. And at the very end of our method, we're gonna want to return the maximum. So I'm pretty doubtful that this works. Yeah, okay, so what happened? Oh, wait, what is the syntax? Oh my god, okay. Sorry, guys. It looked a little suspicious while I was typing it, and now I realize it's because it just isn't a thing. Oh, and I did it some more. And some more. Oh, wow, okay. Let's see if it works, guys. Impressively, it actually works. And it's actually not bad. No runtime, memory. It's kind of slaying. Okay, well, here it is. Making a larger island.